Okay. So welcome everybody to this Conversations with Scientists. Today we have a very special one because instead of a panel, we'll be having a conversation with a very distinguished scientist. So this is our keynote conversation of the year. And we are incredibly privileged to have Dr. Lydia Komaroff with us today. I am super excited to have her on. She's been one of my Latina scientist role models for a long, long time. So it is really a pleasure to have her with us today. Dr. Lydia Komaroff is a molecular biologist, an executive, and a diversity advocate. She's a board member and former CEO and CSO of Cytonome ST LLC, a company developing and manufacturing purpose-built cell sorters. She currently serves on the boards of the Massachusetts Life Science Center, ATCC, an independent nonprofit biological resource center and research organization, and the Keck Graduate Institute. She is a member of the NSF Committee on Equal Opportunity in Science and Engineering, the Advisory Council of the NSF Directorate for Social, Behavioral, and Economic Sciences, and the Committee on Women in Science, Engineering, and Medicine, a joint committee of the National Academies of Sciences, Engineering, and Medicine. She is a founding member of the Society for the Advancement of Chicanos, Hispanics, and Native Americans in Science, SACNAS. Dr. Komaroff held faculty positions at the University of Massachusetts Medical Center, Children's Hospital, Boston, and Harvard Medical School. She served as Vice President for Research at Northwestern University in Illinois and Vice President for Research and Chief Operating Officer of the Whitehead Institute. She served on the boards of Transkaryotic Therapies, Inc., AAAS, and the Advisory Councils for National Institute of Neurological Diseases and Stroke, and the Biology Directorate of NSF. Dr. Komaroff is a fellow of AAAS and AWIS, the Association of Women in Science, Her honors include the Hispanic Engineer National Achievement Hall of Fame, Lifetime Achievement Award for Hispanic Business Magazine, 2008 Hispanic Scientist of the Year from the Museum of Science and Industry in Tampa, Florida, 2013 Women of Distinction from the American Association of University Women, and the 2016 Elkin Morrison Prize from the MIT Program in Science and Technology. She's one of 11 women scientists profiled on the website of the White House Office of Science and Technology, and she is the third Mexican-American woman to earn a science PhD in the US. Her bachelor's degree is from Goucher College, and her PhD is from MIT. So as you can hear, she is an amazing, badass woman. And we're gonna have a great conversation with her. She's gonna start talking about, she's gonna share a little bit about her journey and her career, and then you all will have the opportunity to ask her questions on, career advice, on really anything you want. So without further ado, Lydia, I'll let you take it away.
Great. Thank you very much. It's a great pleasure to be here with all of you today. It's really cool to see how this can bring all of you together. And I can sit here in my office at home, and you can be wherever you are, from the laboratory to who knows where, and also participate. Well, you've heard a sort of a list of the things that I've done. I thought maybe I'd start with my own family background. I grew up in New Mexico. It was my grandfather that came to the States from Mexico during the Mexican Revolution. He came because he'd been coming to the States to work. Back then, you could cross the bridge in El Paso for a nickel. So he'd pay his nickel and he'd come across and spend a while working, usually in the fields or on the railroad, and then he would go back. Well, as the Mexican Revolution got going, as he went back, there would have been battles of various sorts between the Federales and the folks who were revolting, and there would be dead people and guns on the ground. So my grandfather, being an entrepreneurial sort of guy, would pick up the guns and sell them to both sides. This could not go on forever and didn't. Both sides came after him. And in fact, my grandmother's brother was killed in that raid. And at that point, my grandpa decided it was time to get out of town. So he put the family on a train and came to New Mexico by way of Texas and settled in Clovis, where my father was born. My father was born on the U.S. side of the border, so he was a citizen from birth. His older brothers, my dad comes from a family of 15, and he's kind of right in the middle, became naturalized citizens, and they used to have fights about who knew more about U.S. history, because of course to become a naturalized citizen you actually have to learn something, whereas if you just go to school you get whatever you get. So my father was the first in his family to go to school, and that's probably because of my grandmother, whom I never met. She died of diabetes when my dad was in his early 30s. She was a curandera, so she was the one that set bones and knew the herbs. My mother's mother was she and her sisters, their father sent them to college, or to normal school then. It was more like junior college. And he was, on that side of the family, we came to the States back with the conquistadores. The grandfather on that side was one of 4 Jaramillos who came with Christopher Columbus and settled in the Southwest. They had a big ranch in Arizona until the neighboring white farmer cut off Grandpa's water, and that's when he moved to Las Vegas, New Mexico. And he was an interesting man. He had 2 books. One was the Bible in Spanish, and one was the Book of Maimonides in Hebrew. He spoke English and Spanish and Hebrew and Apache. I don't know why Apache, there were other Indians around, but that's what he spoke. And he sent my grandmother and her sisters to school because he didn't want his daughters to marry cowboys. He figured his sons would run the ranch. They needed to know enough to be able to read contracts and to keep track of the figures for the ranch. But he didn't want his daughters to marry cowboys, so he sent them off to college. And my grandmother taught school for a while in a one-room schoolhouse. Her sister, my great aunt Erlinda, was a very tiny woman. She was not quite 5 feet, redheaded. Mom's side of the family comes from the Basque region of Spain. So they've got all redheaded and very fair. We all look like my father. My father's father was puro indio. He had no European blood, which we found out through 23andMe. A bunch of my cousins, I have over 100 first cousins, have done DNA testing, and that has allowed us to ascertain that my grandpa was a Mexican Indian. We don't know which tribe. The markers aren't good enough to determine that as yet. So because my father went to school, as I say, he was in the middle, and he was able to go to college because of the GI Bill. In the Second War, he was a bomber pilot, and when he came back, it was that service that allowed him to go to college. He went to college because he wanted to be a violinist. My dad started playing music at a very early age. Everybody plays something in the family, mostly by ear, but he was picked up on the streets by a guy who knew actually how you're supposed to hold the violin, who taught him how to read music and how to hold the instrument properly. So he wanted to go to college because he wanted to be a concert violinist. He often used to say that if he'd realized it was too late, he couldn't be Yehudi Menuhin or Joshua Heifetz, he wouldn't have gone to college. But he did, and he was a music teacher for most of his life. My mother doesn't like teaching. She said, I have 6 kids at home. Why do I want to have more kids outside of the house? And so she worked as a professional, as a social worker, and their expectations were that we would go to college. And so from a very early age, it was impressed upon us that college was important. I think I decided to become a scientist at a very early age, about 9, I think. Not because I necessarily understood what science was, but because I had this vision that scientists worked in big, white, quiet, empty rooms. And that's how I sort of envisioned the lab, not knowing much about them. That stayed with me in part because I was able to go to a summer science training program that NSF used to have. And so I went off and learned how to do surgery on a rat and take out the adrenal gland. I had gotten interested in the stress syndromes in a book called Calciphylaxis by Celia, who was an endocrinologist in Canada. So that got me going. And when I went to college, I did not want to go to college in New Mexico. I don't think I could have said at the time why that was the case, but I think I had to leave because I think I knew that if I didn't get out of New Mexico to go to college, I would never get out of New Mexico. So I applied only to the University of Washington in Seattle because my dad had a younger brother there, and went there for 2 years to be a chemistry major because I had written to the endocrinology department in the Department of Medicine, and they said if I wanted to be an endocrinologist, I should start by being a chemist. So I was a chemistry major, and that was not an easy major for me. I was having trouble in classes. Actually, everybody was. There was one test where the highest score was 8 out of 100. It was obviously a time when the chemists were trying to test people out rather than teach them the basics of the field, at least there. So I went to my advisor and said that I was having a tough time in chemistry and, what should I do about it? And he looked at me and said, of course you're having a tough time in chemistry. Women don't belong in chemistry. So I said, oh, okay, and changed my major 5 times. I went through history and a bunch of other things before I came back around to biology. The first time I was a biology major, it was very boring. It was, memorize this stuff. And read this book, and it was very dry. But then some new faculty came into the department and taught some really interesting classes, one in animal behavior. And the one that was most influential on me was a class in developmental biology, where as undergraduates, we grew frog embryos and sliced them open over time. We were spending nights in the laboratory so we could cut a frog embryo, freeze it in liquid nitrogen, and cut it, to watch development over the whole period of developmental time. We were using radioactivity and protein synthesis inhibitors and chick embryos. It was really just a whole lot of fun. And on top of that, John Gurdon, the developmental biologist who first showed that you could clone, you could take a cell from a skin of a frog and put it in an egg and get a whole frog, came to talk to us. And of course, we all knew about his work, and we thought that, this old guy would come in. And instead, this red-headed, young, enthusiastic guy came in and told us about his work and told us we should all be scientists. So I think that was what clinched my interest in developmental biology. Well, around the same time, I met a guy who was in medical school. I was a sophomore, and things happen the way they happen. And so he was in medical school and about to graduate, so it was clear that if anything was going to happen, one of us had to change our plans. So that was going to be me at the time, because he was waiting to see if he was going to get drafted or if he would be accepted into the public health service in what has come to be known as the Yellow Berets. This was during the time of Vietnam. Well, he got the letter from NIH first, from the public health service, so he was going to go to Washington. So I transferred to Goucher College in Baltimore, in Towson, actually, it's outside of Baltimore, and finished my undergraduate degree there. That was a lot of fun, and it was very important because there I met, the faculty there introduced me to Loretta Levy, who was a scientist at the National Institutes of Health. And Loretta was an interesting person all by herself. She had started out, she was at the Juilliard School as a classical pianist, and she got bored. And so she wandered into Barnard one day at Columbia looking for something different to do and decided maybe she'd be a scientist. So she started taking chemistry on the advice of the woman who introduced me to her later, who ended up teaching at Goucher. And she got a call, Dr. Funk got a call saying, you have to do something about this woman. She's destroying the chemistry labs. Apparently, Loretta couldn't pick up anything without breaking it. So Dr. Funk took her in hand and taught her how to pipette and so forth, pour one thing to another without breaking it. And she ultimately ended up as a microbiologist at NIH. So when I was applying to graduate school, I knew I was going to come to Boston because Tony had an internship set up. So I applied to just about every school in Boston, Tufts and Harvard and Boston University and Brandeis and you name it, I applied, except I did not apply to MIT. So when I went to go get letters of recommendation from Loretta, she said, why haven't you applied to MIT? And I said, because I don't do math. really well. And that's what they do there. There's all these guys running around with slide rules, which tells you a little bit about how old I am. And so she said, well, you have told me you want to be a molecular biologist. MIT has the best molecular biology department in the world. And if you're serious, you have to apply there. So I did. And to my surprise, or maybe I don't know what I was expecting, but MIT was the only school that accepted me. So I think that's one of the first lessons I learned, is that you will not get anything that you do not ask for. If you don't apply for that scholarship, you won't get it. If you don't apply for the program, you're certainly not going to get in. And I think that was a lesson that has stood me in good stead. And getting into MIT was, for me, magic. It was a great place to go to graduate school. It's one of my favorite institutions. I served, after I graduated, I served on the visiting committee for biology for about 10 years, and I've just started a second term there. My first meeting will be in March of 17. You get a 10-year sort of term. So at MIT, of course, one of the wonderful things about MIT is that the faculty there was superb. And I was very fortunate to work with David Baltimore and Harvey Lodish. I was the first graduate student to have 2 advisors. And that came about because I first we were a small graduate class. And so we got together as a class before, when we were supposed to pick our advisors after we had gone through our first classes. And so we divvied up the faculty, basically. And then we all went to the faculty we had chosen and to get into the labs. And David told me that there was no room in his lab. He was all filled up. You know, he had discovered reverse transcriptase not too long before that. Everybody knew he was in line for a Nobel Prize, just didn't know when. And so his lab was very popular, and he had a lot of postdocs, but also a fair number of graduate students. He and Harvey Lodish shared an office space and a secretary. So I went to Harvey, whose expertise was, David was a virologist. Harvey studied protein synthesis and hematology at the time, the synthesis of blood and hemoglobin. So I went to Harvey and proposed that, it'd be kind of interesting to do protein synthesis of viruses. Nobody really knew how poliovirus was translated. It's a big RNA. Were there internal protein synthesis start sites, or was there one start site and then you made proteins by proteolytic cleavage? And so Harvey, who's very enthusiastic to this day, said, oh, that's a great idea, let's do it. So then I went back to David and said we could do a joint thesis. And he agreed, and so that's how I got them both to be on my thesis advisors. Had a great time there. When it came time to do a postdoc, I learned another lesson, which is I went out myself to figure out who I wanted to talk to. And I wanted to do developmental biology, so I talked to Fotis Kafatos at Harvard, who is using the silk moth as a model. And he accepted me. And so I went back and told Harvey and David about this independently, and they got mad because each of them thought that I had gone to the other for advice and help in getting a postdoc. So I learned that even very busy mentors, maybe especially busy mentors, really want, that's part of their job description, is to help you out as you go through your career. And so I've been really fortunate that my advisors have been both very demanding, but they really helped me to do my best. And certainly David and Harvey both did that. And we remain colleagues to this day. Then I went to Harvard. I did do a stint with Fotis, and that was very unsuccessful. And it's probably because we were trying to do things which really were beyond the limits of technology then. I like to think that maybe we helped Tom Mignatis figure out phage packaging, because we were trying to package a very large genome of the silk moth into plasmid, PBR322, just little. And, you just can't do it. It's not going to work. And it didn't. So, and furthermore, I had to go to Cold Spring Harbor and leave Tony behind. And Cold Spring Harbor was cold, wet, and when experiments don't work, it's just not a happy time, as you all know. So I came back to Harvard, and Arja Stradiatis, who was my lab mate, a crazy Greek guy, came to me and said, I'm working with Wally Gilbert, and we want to clone insulin, and you've been learning how to clone at Cold Spring Harbor, so why don't you come clone with us? And I said, sure, but I got to find a job, so let's just do this pretty carefully and relatively quickly. Well, it was a great project because everything for us, I mean, Arj had spent 2 years on this project getting things ready to go. And when I came in with some critical reagents and some know-how that no one else had. And it made for a very good combination. So that's when we cloned rat insulin and showed that it was expressed in bacteria, and that was a big whomping hit. All of the newspapers picked it up. The journals were all excited. It was we had a very good time that year, and that really was very critical in setting up my career, because that really has made it possible for me to do other things that I might not otherwise have done, and has set me up very nicely with my mentors. Wally Gilbert is he's currently he's become a photographer and an artist. He's in his mid-80s now and travels as much as he ever did. But now he still keeps track of science. He's a venture capitalist. He founded Biogen. He no longer is interested in Biogen, but he is interested in a bunch of other companies that he either co-founded or has an investment interest in. So, and I see him regularly. He was on the board of a company that his son set up that I ran for a while. That was Cytonome. So I think what I learned from those guys is, first of all, there aren't very many of us, people who look like us and who have our background in the sciences even yet, now 40 years plus after I got my degree in 1975. So that means that our mentors, your mentors, are not necessarily going to be people who understand your background or the kinds of cultural and other issues you might have and might be important to you. But that doesn't matter. What you really want is someone who will push you to be your best, and who will who respects your capabilities. A good mentor, it turns out, is not someone who holds your hand all the time. You need someone for that, but you can find that. It doesn't have to be a scientist to do that. Your peers can do that. You can do that for each other. But what you want in a mentor is someone who will push you to be your best, who believes that there's a best of you, who doesn't assume when they see you that there are certain things that you cannot do, as well as other people in the lab. And I've been very fortunate in that all of my mentors, Wally and Harvey and David, all had that characteristic. All white men, but they all had very high expectations of everybody in the lab, and you sort of knew it. What I knew at the time was that I was comfortable with David and with Wally and with Harvey, who were some of the most accomplished scientists at the time. And there were others with whom I was very comfortable and I could talk to and ask questions, and that was all great. And they weren't necessarily the people who didn't kick me in the behind when I needed it. But there were other people who were maybe not even as smart as those guys, but who were certainly as accomplished and as recognized, with whom I did not feel comfortable. And I didn't really understand what was going on until very recently, when I got interested in some of the work that psychologists have done about human inherent bias, implicit bias, and stereotype threat, which maybe I'll talk about a little bit. These were folks who looked at me and made assumptions about my abilities and what I could do or could not do by the way I looked. And I could sense that immediately. And I'm sure you've run into that and you can sense it too. It's important that you know that is it's a human failing. It's not you, it's them. It's actually us. It's something that we all do. It's built into the way our brain evolved, as it turns out. And so I think it would have been useful to know that earlier in my career. But my radar was such that I picked the right people to work with and for over time. When I started my own lab, I made some really classic mistakes that are mistakes that women in particular, but people of color in general tend to make. We have trouble saying no when somebody asks us to do something. We're eager to give back to the community, so we sort of want to help the students, and because we are the minority in the group, often, there were in my department, in my first job, there were 5 women and 5 men. there was one black man, and there was me, the Hispanic, and the two of us were often asked to be on essentially any committee position that came up. And the two of us, between us, I think we taught more classes, we were on more thesis committees than anyone else. So that meant when tenure time came, it was a little difficult. I hadn't published as much as I should have. And that's a really important lesson. If you want to be a scientist and you are in an academic job, publish. You have to do, that's your main responsibility. You can't change things about the way science is run or done or students or anything unless you're at that table. So it doesn't matter if you decide to go into academia or you decide to go into business or you decide to go into law or anything that uses your skills as a scientist. You have to get as high as you can in order to be able to make a fundamental difference, in order to have a significant voice at any table. So now that I'm semi-retired, that's why now I'm spending a lot of time going around talking about implicit bias and what I've learned about what's known out there about how it is that the human mind works and how this is actually data which is quite rigorous, and us hard sciences, as we like to term ourselves, the physicists, the chemists, the biologists, mathematicians, need to understand that we can learn from our colleagues in the social sciences, and that if we were to take that seriously, we would make more progress in incorporating the folks in the country who are currently now not represented in so many places. And I sort of earned my chips, so now I'm spending them. And to my surprise, I've had a fair amount of success with the talk that I've given, and I'm doing that a lot these days. In the meantime, I'm also, while I was at Northwestern, I learned a lot about business. I mean, I was sort of interested from the beginning because I was there when Biogen was just 4 of us in Wally's lab, and a thought in his mind. We didn't know until the night that we finished writing the PNAS paper that described the synthesis and expression of insulin, that he was planning a patent. And he took the 4 of us he felt were co-inventors. He said, we stayed up all night rewriting the paper that he had drafted. And he said, well, when you're done, catch a couple of hours sleep and then meet me at Fish and Neve, which was one of the big law firms. And that's when we learned there was a patent and we were on it. That patent was very nice. It bought a condo in Chicago when I went there to be vice president for research. We got royalties for 17 years, rather cool. So that really was the start of an interest in business. And when I came back to Boston from Northwestern, a guy that had been a lawyer at Biogen was now the CEO of Transkaryotic Therapies, which was a company that was making, and it was like Genzyme. It was trying to make large molecules to treat rare diseases. And it was on an upward growth curve, and Mike asked me to be on the board. Wally was on that board. There was a bit of an insurrection because Shire said, we would like to buy you. And the CEO didn't like that idea. And so the board split. There were only 7 of us. The board split. And we decided we needed the chairman of a board of a publicly traded company and the CEO have to be like twins. They talk to each other all the time. It's a very close relationship. And so you must respect and trust each other. And that respect and trust dissolved between these 2 individuals. So we knew we needed a new chairman of the board, and we kind of assumed it would be Wally. He was the most experienced person on that board, other than the chair, who had been the CEO of Merck and a few other big companies. But after an 8-hour meeting, which we thought would be maybe a couple of hours, I ended up being chair of that board of directors because people felt Wally had already decided the company shouldn't be sold. I was the only woman on the group, and I hadn't expressed an overt opinion about whether the company should sell or not. And I rather suspect that each side thought that they could manipulate me, since I was far and away the least experienced with business of any of those guys, and they were all guys. But we went through a process that was, I had guidance not only from Wally, who was there he was very knowledgeable, but also from the dean of the business school at Northwestern, who helped me understand that bankers do best, and lawyers, that the way things used to work, they got the most money if the company was sold. So Don Jacobs, who was the guy at Northwestern, said, hire in bankers and lawyers whose fee is independent of the outcome. So we did that. It turned out we had 2 sets, but we did have advice from a really good lawyer. She's now the head of McGrath Cravath, which is the biggest and most prominent M&A law firm in the country, probably in the world at this point. And at the time that she came to work for us, and she worked for us for a breathtaking flat fee plus expenses. She had monitored and had been responsible for the Time Warner merger. So she was already a big time person. Turns out, even though her name was Faiza Saeed, she was a short blonde. I expected someone who looked Middle Eastern, and she grew up in California. And very smart woman, and we had a great time, and we ultimately sold TKT for $1.6 million, survived a couple of lawsuits, one of which included Carl Icahn. There's nothing like being deposed in front of 12 lawyers. It's an interesting experience. Kind of fun if you like tennis and competitive games, and I do. So that was an interesting experience and set me up in an interest in business. I have to say I was the last of my MIT class to get involved in business. When I started in graduate school at MIT, the faculty would say, if you want to go into business, you're a failure from the get-go. Only people who can't cut it go to business. By the time I finished graduate school, every single one of them had an affiliation with a business. They had started one, they were consulting, they had patents, the whole bit. And that was, of course, because of the advent of recombinant DNA and what it meant for the field. So that led me, Northwestern was a wonderful experience. And when I came back after the Whitehead Institute, Wally said, why don't you talk to John, his son, who had started a company. And that company, I said I'd help him out for a year, and I ended up staying for a decade and became the CEO, went out, found money and a partner. The company's on its way, and I am failing retirement at this point, giving talks and being on several boards, including ATCC, which is a company that's interesting company because it's a not-for-profit, but it is a reagent supplying company and provides cell lines and bacteria. So that's my story. You've heard I'm married. I have no children. You know why, because of all those cousins and siblings and so forth. I enjoy kids when when other people have kids moving out, we have kids moving in because they have an aunt to talk to who doesn't have other things to worry about, other kids. So that's me, and I'm open for just further discussion of any or all of those things I touched upon. Thanks.
Thank you so much, Lydia, for sharing all of that. Questions, comments? I could start, and I could probably take over the conversation, but I don't want to do that. So you can raise your hand if you have a question, and we'll call you out. You can type it out if you want to. Don't be shy.
I hear the cookies. I'm waiting to hear from someone else.
Ivelisse, were you raising your hand, or were you just waiting?
Yes.
Okay.
No, I may have missed this, and I read her biography, but I just wanted to make sure. What is she doing right now, and how was that transition from being in academia, going to a postdoc, going to a company, and now where you at, which is what I missed.
Okay, where I'm at now is failing retirement. I left the day job, which was management of Cytonome, which is the company that I was affiliated with. It's a company that builds cell sorters. It's primarily an engineering company. So I guess that's the other thing I tell you. I started out as a molecular biologist and a gene jockey. And then I became a Hun because, molecular biologists sort of entered everything. So we did cell biology, some neurobiology, some endocrinology. Well, I had my lab at Children's Hospital in Boston. And then And then I became an academic administrator. And then I joined this company and ran it and became an entrepreneur and raised money and all that good stuff and became the CEO. And then about a year ago, I stepped out of that position. I remain on the board, but I don't have a management position. It's very weird. When you retire from an academic job, you are nevertheless forever affiliated with the institution. When you leave a company, it doesn't matter if you're on the board. You don't have a business card anymore. So I've taken to putting that, you know, every time you fill out something for a meeting, you have to put your affiliation. So I put none and several because I'm on 3 or 4 boards, and I do a lot of consulting type stuff. But I don't have a formal, I haven't started a little consulting business. So I put none and several. And that actually shows up on some of my name tags now. So I still really have trouble figuring out what to call myself because I'm not exactly retired. One of my good friends, who's an expert in Latin American literature, reminded me that one of the Spanish words for retirement is jubilación, and I should enjoy it. So I try to enjoy at least half of it. And the other half is doing things like this, giving talks. I'm writing up the thing on implicit bias and how that has affected the slowness of the incorporation of minorities into STEM fields. And I'm giving that talk all over the place these days. I've given it at MIT and Hopkins and Tufts and BU, and I'm going to be giving it in California at Stanford and at the Keck Graduate Institute and at a number of companies. So I guess right now I'm sort of a freelancer. And the transitions were for me fairly natural. If you call walking off a cliff natural, because they often involve doing something very different from what I had been doing before. And I think that's another important thing to learn is that whatever you think you'll be doing in 10 years, it'll be different because the world will be different. And the thing to concentrate on as your graduate students is what you're really learning as scientists. The subject matter is not so important. What's really important is the problem solving, critical thinking, all of that kind of stuff stands you in very good stead no matter what you do. That's what made it possible for me to be a really, I think, effective vice president for research, is the ability to know what are important questions, where to put resources, stuff like that. And in business, it helps too, because you know how to solve problems, and there are going to be a lot of them. So that was helpful. So the transitions were not bad because every one of them offered a challenge and seemed to have some aspect that was fun. And that's another important thing for me. You know, life is hard and so is work, no matter what you do. And so I figure you really ought to have fun at some part of it at least. Sometimes that can take a stretch. My sister is a judge now. She hated law school. She just really didn't like it at all. But she really likes being a lawyer. So you sort of have to know what it is that at least the next step is and get whatever you need to do that next step. And then keep open to opportunities that may be out there because you never know where they'll be or what they will be or where they'll take you. My going to Northwestern was a good example of that. My husband is at Harvard and he is really happy there. He has what is for him the perfect job, or had. He's now half retired as well. So when I got the offer to go to Northwestern, my first inclination was to say, why would I go to Chicago? I'd only been to O'Hare, and so that's not a great place to get a good impression of Chicago. And secondly, I knew that there was no way Tony was going to move. So I told that to the headhunter who called me up, and she said, you know, you have said you want this kind of a job. You don't have to take this job. But if you really want this kind of a job, you have to look at this job. So I looked at the job and I fell in love with the institution and with the guy who would be my boss, who turned out to be another great mentor. And how he is a theoretical chemist who was VPR at Northwestern, very thoughtful guy, who taught me some of the ins and outs of administrative stuff. And so I went and we made a deal that my sister-in-law told us. We were arguing about this or talking about it when we were visiting her. And she said, you two, you never see each other anyway. You travel so much and you never go with each other because it's always for something professional. So you'll probably see each other more. And we said, that's probably right. So what we did was we got together every other week, and that was a little no work, which was a first. We had never spent weekends, whole weekends. I mean, really, who has a whole weekend? But every other week we took the whole weekend with no work. And so we would have a little honeymoon, often in Chicago because it's a great city. But sometimes, New Orleans or San Francisco or, someplace cool. And then we worked like crazy for 2 weeks. And that went on for 7 years. And it worked for us. And but 7 years can be long, so it's time to come back. That was a long-winded reply to your question. Next.
All right, who's next?
I have a question. It's Jenny.
Go for it.
Hi, Jenny.
Hi. So what would you say, it's actually like a two-part question. What would you say when you began your career was one of the main challenges for scientists? And if it was resolved, how was it resolved? And how would it compare today with the challenges that some scientists have today? And what recommendations would you have to resolve that?
Do you mean scientific challenges or personal challenges?
I would say more with scientific, with how we promote our work.
Oh, we don't do as good a job as we didn't do then. The fact of the matter is that not enough of us have learned how to talk to the public. We're a little bit gun shy because, if you talk to a reporter, they can get it wrong. And it's sort of embarrassing and difficult when you see your words misrepresented in the newspaper. On the other hand, if we don't talk to the press, then it doesn't get out there. And so it's really important that we talk to people, and we don't do that very well. That was a challenge then. I mean, back in the 70s when recombinant DNA was around, when that controversy started, there was very much the same kind of fuss that there is now over genetically modified organisms. So that people just felt that this putting genes from one organism into another was dangerous and could result in a worldwide plague, and we'd make Frankengene and the world would end and all of that stuff. And some of these people were scientists who were really had a political bent. And that was a little weird because we all thought we were leftists and all of a sudden we were on the other side. So it was a time when it was a challenge, and some people will listen when they know what the story is, but you can't talk down to people. You have to meet them where they are. What I found to be really good practice for this is talking to kids. And by kids, I mean third graders, fourth graders, fifth graders. If you can talk to kids, they will ask you anything. And you learn how to respond on your feet with respect for the children, and that'll stand you in good stead talking to anyone else. And of course, talking to your family, I mean, I have to explain to mom and dad about, they didn't know from protein synthesis, but poliovirus and diabetes, those were things that a starting point where we could talk about the science, and then they talk to their neighbors and so forth. So I think communication from scientists to the public was a critical problem then. It remains a critical problem, but one which I think we're more aware of. AAAS now has a program where they try to take scientists to talk and work on public communication. And right now they're focusing on climate change. Over time, they will do different things, and that's become a major focus of AAAS at this point. I think the other challenge that we face, and it's one which goes up and down, is money. Right now it's difficult to get grants. It is a fact that more people are being trained in some sciences than there are jobs in academia. And we don't, as a field, do enough to tell people what their options are. It's really exciting to do the science. It's great fun, but at some point you really want to make a living. And we haven't done a very good job, I think, in telling people what the options are and how a degree in science, a PhD, is not a degree of limitation. It really should be considered a degree of problem solving. And that's one reason I'm involved with the Keck Graduate Institute in California, because they're an institution whose sole purpose in life is to train people for the biotech industry, to take scientists and give them the tools that they need to enter into the pharmaceutical company. That board is primarily people from the pharmaceutical industry and biotech. There are a couple of us who have academic leadership positions in our background, but for the most part, they're from the industries. So I think those are major challenges. And then, of course, there's the problem that I'm here to talk about, that I've talked about a lot, which is despite the fact that we may be training too many scientists for the academic jobs, as a society, we remain remarkably science illiterate. We are not, as a society, knowledgeable about science. And I think that's partly our scientists' problem. So I think those are the big problems for science as a general field.
Thank you.
Hi.
That was great.
So vote, by the way. It's going to be really important to vote.
Yes.
Hi, I have a question.
Sure.
Maybe, if that's okay.
Go ahead.
Yeah, hi. I'm very interested in a few topics that you have mentioned, including implicit bias, your work on talking to people. And my question is, to which audiences have you been recently talking about implicit bias, let's say within the past 3 years, and why specifically those audiences?
The audience that I'm out to reach with my implicit bias talk are the faculty, the administrators, and the leadership of institutions, particularly Research One institutions in the country, because these are the institutions which are making the least progress in terms of incorporating minorities into their faculties. They've done a reasonable job with students, but not such a great job with faculty. And so that's where I've been giving the talk. I try to do it in the following way. I start by saying that it is a result of the evolution of the human brain. That the data that we receive, even though this is a very marvelous little piece of machinery up here, still the amount of data that comes in every second through all of our senses is enormous, and it cannot be handled by the mechanism up here. And so methods have been evolved to deal with that, to filter information. And as a result of that, we have a way of thinking which is a gut response to things, so that when we see a person, we make immediate associations which are dependent in part on our cultural upbringing. And we all do it. It's not a white man's problem. It's a human problem. And so if I can start that way, people take away the finger pointing. And then I talk about the science behind implicit bias and decision making, and some of the things that have been done that seem to ameliorate the problem, and some institutions that have been successful in changing the way in which they think. And it's sort of in the air right now. A lot of people are talking about it, and I am finding that I'm getting a responsive audience. Today I was at the School of Public Health at Boston University, and the dean came, and the chairman of epidemiology came, and 2 chairs from the Department of Medicine came, as well as the usual assortment of graduate students and postdocs. So some of the audiences have been small. None of them have been overtly hostile. I have been taken aside on after some of them, and people have said, well, we're not prejudiced. We are not biased. We select for merit. So I have incorporated into the talk the experiments that show that we don't make selections that way. Joe Handelsman, who's a chemist and who is now in the in the White House Office of Technology and Policy, she runs a biology thing there, did a study where she sent to almost 400 faculty at Research One institutions across the country 2 CVs, a man and a woman, and she asked people to evaluate these CVs and indicate if they would hire them first, and if they hired them, what salary they would offer, and what kind of mentoring opportunities might be there for these people. And the result was that everybody old male faculty, young male faculty, old female faculty, young female faculty, all found that the male, even though these CVs had been constructed to be identical in credentials, numbers of papers, quality of papers, references, etc., far and away, most of them felt that the male was more competent by a substantial amount, and they offered the man more money, and they said they would provide more opportunities. And they weren't thinking about it. It's just a response. When this is brought to people's attention, and they recognize that this is a human issue, not a problem in many of the studies that we have. I mean, explicit bias, there's no question that it's still there. But very frequently in the academic realm, people are of good intention. They just don't know. They don't know that they respond without thinking, that the biases are so deeply built in that you act without knowing what you're doing, in a sense. And so I found that people are, they're a little bit amazed that the data is as strong as it is and that it comes from as many fields, and they recognize themselves in it. And I think it helps to say, this is something we all share. This is something we all have to work on. It's not, as I said, a white man's problem. It's a human problem, and we can deal with it. So that's how
Thank you.
accepted it.
Thank you.
And
okay, we have about 4 minutes left. So do we have a final question from you guys?
I like your chats, by the way.
I have a question, and it's related to the management position you had in industry. I was just wondering, what were some of the challenges that you encountered when you did that switch, and how did you go around that? Especially, we come from science, we probably don't have a background in business. Most of us won't probably go back and study business either. So I'm just wondering.
Well, if you are interested in business, you first of all have to be interested in business. And that means I was reading the business page of the Sunday Times for a long time. There's a little thing in the corner. It's very short. It's called CEO Corner. And it just is interviews with CEOs of people of all kinds of ages and backgrounds of all industries, and how they got to be CEO and how they hire and what their philosophy of management is and all of that. You can learn a lot from that kind of stuff. I personally think that a lot of my skill, I learned being the eldest child in a very big Mexican-American family, frankly. I learned about cooperation and competitiveness. I think my biggest challenge was asking for money. That's hard. And I don't like to do that anyway. And it's sort of weird to have to go and say, I really need your money. Because if you have a company, a small company as we were at the time, a startup, there's 3 rules. Don't run out of money, don't run out of money, don't run out of money. Because there is no, keep the lab going, maybe we have to downsize some of the techs, but the lab keeps going, you have a university salary. No, run out of money and it's over. So there's a certain imperative to getting the money, and I learned how to talk to people and make the case. The elevator speech, turns out you can practice that. I think I had learned it earlier, but one thing I certainly learned then was that people don't know how you're feeling. They only know how you act. And if you act confident, they think you are confident. And pretty soon you'll think you're confident, as it turns out. And so that helped, just to pretend that I knew what I was doing when I was asking for money. So that was a challenge. The other challenge was that most of the people in the company are engineers, because we were building machinery after all. And so engineers have been trained a little bit differently. They think a little bit differently. And so that it meant having to learn a different culture in an interesting way. So I think those were the biggest challenges. Managing a board is also a good problem, but if you have lots of aunts and uncles, you've sort of got some practice there too. So part of it is applying the skills that you have in a new arena, And the other is that if you're seriously interested in an area or want to explore it, you have to explore it. You can't explore it without doing some investigative work. And it can be as simple as reading the Sunday Times online every now and then, reading that column in particular, or picking up books on business. I found those really interesting. I found them interesting because they provided information for me as a woman in a man's world as much as anything else, but they turned out to be very useful later on in terms of business relationships. So I like to read.
Okay. Do we have time for one more question, Lydia?
Sure.
Okay. Anybody take the last one? Yes, no?
Thanks for coming, guys.
Okay, well, if we don't have any more questions, we'll wrap up. Thank you so much, Lydia, for being with us tonight, for sharing your experiences, for being so candid and sharing your wisdom. We were delighted to have you. So if would you mind if we share the email with the students if they want to contact you with further questions?
Oh, not at all. That would be fine. By the way, I see in one of the chats someone says 7 years is a lot, but without kids it can be done. One of my husband's mentees is a woman who is a full professor at the University of Washington. She's just moved to a new medical school now on the other side of the mountains. Her husband is a full professor at the University of Denver. They've been commuting now for 15 years. They have 2 kids and a dog. And I admit that, I mean, that's hard. But you can, if it's important to you, you will make it work. And if it's not important to you, don't do it.
There you go. And with that, we end our conversation. We'll be sending you Lydia's email later tonight. So thank you, everybody, for being here. Thank you again, Lydia, for being with us. And we will see you guys next time.
Thanks, guys, for coming. I enjoyed it.
Thanks, Lydia.
Thank you very much.
Bye-bye.
Bye, everybody.
Good night.
Good night.
Bye.